Good morning, everyone, and welcome to the Night Open Circuit number 7, the official IEEE UCF podcast. My name is Gudaro, and I'm the current secretary for IEEE UCF and an intern at Collins Aerospace. Today's hosts will be Juan Battaglia and Fernando Ariondo.
Hello.
And today's episode will be featuring two very talented engineers from Collins Aerospace, the best aerospace company in the world. Sorry, Boeing. Sorry, Lockheed. Today we have Jonathan Vodopich, a manufacturing electrical engineer at the Manchester, Iowa facility. And we have Alexander Caracciolo, an electrical engineer in Cedar Rapids, Iowa facility. Both engineers work within the commercial aviation business unit and primarily focus on flight displays. Welcome to the show, guys.
Thank you.
Thanks.
Yeah, thanks for being here. So I would just like to know, what are your roles specifically, in the company? And if you can tell us more about Collins Aerospace and Raytheon technology, how does that work into each other?
Sure. I'll start off, John.
Go for it.
So Collins Aerospace is one of basically 4 companies under the Raytheon Technologies umbrella. So under Raytheon Technologies, there's Collins Aerospace, Pratt and Whitney, Raytheon Intelligence and Space, and then Raytheon Missiles and Defense. So the Collins Aerospace side of the business basically focuses on solutions from tip to tail of the aircraft. So as you go throughout a commercial aircraft, we basically have solutions either in place on just about every aircraft or have a solution that could fill that spot on an airplane. So specifically, my role in the company, I work in new product introduction as a manufacturing electrical engineer. So my role is to help transition products from the prototype phase into kind of the standard production world where we're going to make X number of widgets to support all the different platforms that are out there.
Yep, and then so my role is fairly similar to Alexander's, but it's different. So being a manufacturing and electrical engineer, I'm more focused on the day-to-day products kind of stuff. The production flow, production testing and acceptance of already existing products. I do help Alexander quite often on the NPI side and development of test setups and displays and stuff, but a lot of my focus is on the existing production stuff.
Yeah, so our titles are MEE, so Manufacturing Electrical Engineer, but we like to rename that acronym basically, Masters of Everything Engineering. We literally dip our hands in every aspect of the products and getting them through, the various production phases and helping them, especially my side of the house, getting them ready to be manufactured.
So Alex, you do more of kind of almost like design work, and Jonathan works more with products that are already came to life in a way. So
my role is really to set John up for success. So I help kind of work out the kinks. And when I say me, John and I have a great working relationship. So we kind of do this concurrently, but my formal role is really to make his job easier. So my job is to kind of find the bugs in the product. What are the bottlenecks? What are the things that are going to make this not manufacturable? And as we're going through these prototype builds, I'm documenting and writing down all the issues we run into. So we try to address those before we try to make these in mass. So that's kind of where my role sits. But John is very involved. I mean, I don't want to make a decision that he's not going to want in the end. So there's a lot of open communication, and we really try to help each other out and make the best solution we can going forward. Yeah. So we advise design engineering a lot on the product.
Okay, that makes sense. And you guys both got hired around the same time, or that's what it looked like from your LinkedIn. You guys got hired around 2019, a couple of months apart. Is there? Do you think any coincidence that you guys ended up at Collins around there at the same time? What brought you kind of both at the same time to Collins?
So there wasn't a mass hiring event or anything that they were trying to do or trying to expand. The plant that I was, that I currently work at, they, just needed a couple more engineers, and to be perfectly honest, I was just applying randomly one day for jobs. And then, so they called me back for an interview, fly me out, kind of show me around, tell me about the job, and, so it just ended up out here.
Yeah, and for me, I was engaged at the time to my now wife, and we were trying to figure out where we're going to live, where we're going to make our life. She's an engineer as well, and she had already kind of
Oh,
planted some roots in Iowa with a family engineering firm. So I was like, well, definitely, I think Iowa's going to be it. So I as well just kind of went out on a whim. I will tell you that aerospace in college was the furthest thing from my mind. I swore it off. I was like, aerospace is only RF, and I don't want to do that. It's not my field house. But then I started, getting more experience. I started off in an appliance company called Sub-Zero Group up in Madison, Wisconsin. They made high-end luxury appliances. I worked as a test engineer from them, and really got my hands dirty. Got introduced to a lot of different things. Got to see the design phases, the engineering phases of product development, as well as the factory side support. And then when I was making my transition to Iowa, the job description of an MEE basically matched exactly kind of what I was looking for to continue on doing. So
so
All right.
I think it's really interesting. Kind of like sidetrack a little at this point. That a lot of people tell me when you're in college, you don't really know what you want to do, or you don't really expect to end up where you end up. Basically, for example, let's say I'm doing power. When I'm like 10 years from now, 30 years from now, I'm gonna end up doing RF work. So when you guys were in college, do you like think you end up where you are now, or do you have like something else that you still want to achieve and do, essentially, as an electrical engineer?
I can tell you that I certainly didn't end up in the role or the location or really the company that I ultimately was hoping for when I was in college. I was in college, I was much more interested in like prosthetics and robotics and that kind of stuff instead of um, you know avionics and that kind of stuff. But I actually ended up having an internship at a aerospace company, technically the same one now. So it's just something that I'm like, oh, this isn't too bad. I kind of like this. I like the culture. I like all the products, super cool. So just ended up working out.
Yeah, you majored in mechatronics, right?
Yeah. So most people, when they hear mechatronics engineering, they pretty much go, well, what the hell is that? I never heard of that before, because it's not a very broad or popular degree. So a lot, you could pretty much think of it as like a combination of electrical engineering and mechanical engineering, with a little bit of like computer science stuff sprinkled in. And just due to the location, there's actually quite a bit of like industrial engineering stuff sprinkled in also, because that was the other engineering degree my college offered. So all the way throughout college, I always really liked the electrical engineering side of it, way more. The circuits, the digital circuits, all that kind of fun stuff. So we, when I graduated, I was kind of definitely more looking on the electrical engineering side of stuff.
That's really nice that you got to see like engineering from a really unique point of view, because I know a lot of kids, especially me at one point, were considering doing mechanical, right? And I didn't really know if it was mechanical or electrical was the right path for me. So I think it's cool that you got almost to get a taste of both and then make a decision.
Yeah. And to be honest, it really helps in my job now, because as Alexander said before, where we're MWEs, where the master of every engineering, not just electrical engineering, just because things pop up day to day. We have to help with a lot with electronic side, but then we have to be like, oh, this doesn't fit at all. Do this to make it fit in our test fixtures and all that kind of stuff. So it's certainly helpful to have like a broad experience in my job.
yeah, I think to Fernando, your point of in college, you don't necessarily know where you're going. That's a great thing. Keep the doors open and learn as much as you can, because especially like John was mentioning, yeah, we're we really focused on the electrical engineering side in our training, but we have to work with mechanical engineers, industrial engineers, product design engineers all the time. And being able to to see things through their lens, even if it's just from prior experience or from working with them, makes our jobs so much more enjoyable when, you know, we can communicate and things can flow on the same level because they understand where we're coming from, we understand where they're coming from. And even if you don't have the degree in mechanical engineering, you can appreciate a lot of what they do. So keeping those doors open and you know, keeping the blinders off initially really helps you get a good foundation. And from there, the sky's the limit. You can go wherever you want.
That's interesting. I never thought about it that way. I'm sorry. Did I just cut off? My internet stopped for a second.
Nope.
Yeah,
Nope. You're good.
you cut off a little bit, but you're good.
Okay. But no, actually, I think I honestly respect that a lot. That you did that major, because right now I'm taking like a mechatronics class essentially,
Yeah.
and I don't know, I just can't. Doesn't work in my brain. You know, those mechanical systems. I'm so used to like the way circuits and like that physics works, and now to like do kinematics or like stress, strain. I'm just not used to it.
Yeah.
So,
Yeah. It's definitely a rather shift in thinking, you know, in problem solving than the electrical engineering side. So
cool.
Yeah. Kind of circling back almost, right, to when we were talking about how Raytheon is kind of the company above that kind of owns Collins at this point, right? That happened pretty recently in April 2020, like last April. So it's almost been a year now. Do you feel like things have changed a lot in that year? Like, have there been a lot of projects that get canceled? Because it's kind of a unique perspective to be in the company when something like that happens.
Yeah, so from my perspective on the new product introduction side, I have not seen anything cancel. In fact, we've been able to enhance and kind of grow our products and projects because now we have all this extra technology in-house that's, you know, now under one roof. So our group has been, you know, really kind of slammed, just taking it all in. And I'd say that the opportunities, and especially being a now solely focused aerospace and defense company, are just endless at this point. There's so many things that we're coming together to do, and it's pretty amazing.
Yeah.
Yeah. On the you know, like the manufacturing, you know, production side, there hasn't been a whole lot of changes as far as, you know, like the Raytheon stuff. You know, that they're bringing more work, you know, which is good. You know, developing more displays, which is always good. You know, but the biggest change of stuff, you know, the last year, of course, has been COVID, as you know, you might imagine. So, which that did, you
Yeah.
know, at least on our that did actually, you know, delay quite a bit of projects for us on site, and, you know, upgrades and all that kind of stuff. But
Yeah, I imagine COVID probably outshined a lot of that process of merging the companies and stuff.
it certainly did, because I think the merge date was like April 1st or something. So, you know, that was
Yeah.
like a week or two after, you know, the you know, COVID really started coming on. So
Yeah, I wonder if they, when they were making that decision, they knew what was going to be ahead of them for the next year. Like,
there's no way, but it's probably a good thing, at least as far as, like, you know, job security for everyone goes. You know, it hasn't been a great year for, you know, commercial avionics or you know, commercial aerospace industry, but since, you know, we're merged with Raytheon, and you know, they do a lot of government stuff, you know, the total impact of the business has been not as bad as it could be. So
yeah, you always need the Army always needs avionics at any point in time, so
yep.
that's true. But you guys said you both work in flight displays, right? Like, partly at least, or
Yeah,
mostly?
so my role is new product introduction avionics. So technically anything, you know, in the cockpit or that supports the cockpit as far as providing data kind of falls under the avionics umbrella. So those are the things I could work on. To date, though, majority of the things I support have been flight displays, and actually the majority of them up in the plant that John works at. So we get I'd say up until recently, because we just transitioned 2 products into his facility, we were working with each other daily, at least on a morning call to get the day started, and then if not, various times throughout the week. So, but yeah, I primarily have been working on flight displays, and it's been really exciting.
Oh yeah. Well, to somebody that doesn't know anything about what a flight display is, how does a pilot use a flight display, and like what does it do?
Sure. So there's really 2 categories of flight displays, and then within those categories, you can break them down even further. But there's what we call heads-up displays. So you're thinking about, looking out through a windshield or through a visor or through a helmet if you're like in a fighter jet. That's something where your eyes are able to stay kind of on the horizon through the front of the aircraft, and you see everything. But then there's also this extra stuff, in your field of view. Then you have your heads down displays. So this is kind of like your speedometer in your car. So you have to kind of look down a little bit to view the information. And then within those different categories, there's different things like touch screens. The beauty of a display is the fact that you're replacing a lot of the legacy avionics. So think of all those little indicator lights and gauges in an aircraft with a display that can display what you need when you need it. So the pilots can use a display for just about anything. They have maps, and they can see the weather radar. They can even see their flight plan. They can go through their checklists. They can use them as keypads. Most of the displays that John and I work on are either adaptive flight displays or multifunction, meaning that what we're displaying on them is not static, that the information can change and be updated as to what's relevant going on. So as they're taking off, they may have something on a display. And then once they're cruising, they may need some other information. Same thing for landing, and it may be totally different. So those are the primary use cases. But the flight displays can be used all over the place. So
That's actually kind of interesting, because does that mean like the software also gets made in-house, or is it almost like a car display where you have like third-party apps on it as well?
I'd say it depends on your customer. We have a huge group of software engineers that work on either an operating system or a base architecture for the software, and then, depending on the platform or who's the customers, they may develop their own applications to write on top of that. But a lot of the lower level where we're receiving, the weather data or kind of the synthetic vision type side of things, a lot of that processing is done locally to that display, and that's kind of all in-house built stuff. And then the customer is the consumer of that data, and they can use that and display that however they want.
There's certainly not any like app stores, so where you can be in mid-flight and download anything.
Yeah.
Though it's got to be very specific software and approved by FAA and all that kind of stuff. So
Yep.
Yeah, I imagine they're not watching movies while they're driving or flying.
They can't download Netflix on these, so unfortunately for them. So
that's the future right there.
Yep.
So Alex, you mentioned that you and John work together. So when you say that, do you mean like more virtually now that, because of COVID, or is it like more physically, like going to lab, have meetings?
So John and I geographically are located probably about an hour apart from each other. So even before COVID, there was a lot of virtual meetings, Zoom, Skype call type things. But I had the opportunity a lot to go up and support John, especially during the early stages of, hey, we're bringing you this new product. You've never seen it before. Let me kind of introduce it to you. I've been to some engineering labs and got demos of what this thing is. I've worked with our test engineering group. Here's kind of the solution that we're proposing to be able to test these things before we ship them out. And so we get to work face to face in those instances. And the reverse is true. John's come down to visit us, and he's seen things in engineering labs and prototypes like that as well.
So do you think COVID didn't have that big of an effect on your work habits, or it did? Since it was virtual already, in a way.
Yeah. times and not being able to come on site, you kind of almost become a manager of people. You have people in the plant that are working as your hands and legs for things that you need done that you could normally walk into a factory and just do yourself. So that's definitely been a shift. I very much enjoy the social aspect of being able to work side by side and build trust and relationships with the people that are working on these products. So that's probably the thing I'm missing most right now. But from the other side of it, yeah, we were ready to work virtually, I think, just because of our separation prior to COVID.
Is there like any steps Collins Aerospace is making it so like you guys can go back to the labs and travel more? Or do you think they'll keep staying like virtual?
You're gonna have to repeat that one, Fernando. It cut out.
Yeah, no, my thing cut out too. I was saying, do you think that Collins Aerospace is gonna stay more virtual now because of COVID? Or no, yeah, because of COVID, you know, the effect that had on everybody. Or do you think they're gonna take like more steps to like make it more, you know, go back to the lab, work on the things, travel more?
I'd say it's definitely a hybrid of both. COVID definitely has forced the invention and the innovation of being able to work virtually. And there's definitely positions within the company that I think will be able to work, you know, remotely or semi-remotely, kind of a hybrid model where they're only in certain times of the week for the long term, particularly like buyers and our finance folks that don't necessarily have a lab that they need to be in or a production line that they have to be on. And the other great thing about COVID is, well, not COVID, but the impact it's had is the fact that some of the work has also gotten more flexible. So you're able to do a little bit more kind of when it's, you know, convenient for both of us, like John and I can work on something that we're not necessarily framed by an 8 to 5 day anymore. If we need to stay a little later or work a little earlier or do something in the middle of the day, we have much more flexibility to get that kind of stuff done. John, from your guys' side, being more on the essential worker side and being in the production facility, you guys notice any changes, or do you think any long-term effects of this COVID working environment or sticking around?
Yeah. Well, I guess we'll see. I mean, you know, the last year, because we used to have visitors, you know, like every single day to our plant, because, you know, like the plant that I work at, you know, is like, I don't know, 200 or 300 people, and, you know, the plant that Alexander originally works at is, you know, what, 8,000 or something. You know, so we got a lot of, you know, visitors, you know, design engineers, these people, you know, those people, and that all the time, you know, before. And, you know, since, you know, just to help, you know, fix this or fix that, or, you know, see this, see that, you know, since of course COVID happened, you know, all of that most of it has gone, you know, virtual, you know, so, you know, if we have problems with our test equipment, you know, our test engineers have to, you know, remote in instead of just being able to come up. So I do kind of expect once, you know, a lot of the restrictions lift from that stuff to kind of go back to normal. You know, be able to get like on-site support is typically just easier and faster than, you know, remote. In some cases, it depends on what's actually the problem, what the problem actually is. But yeah, I guess we'll see. As far as like, you know, the plant that I work at, it really hasn't been that much difference as far as like day-to-day stuff since COVID. You know, of course there's masks, of course there's social distancing, but you know, pretty much my whole plant was, you know, the required workers before, you know, so pretty much everyone's still there.
That's kind of like a really good thing that you guys feel like not a lot has changed from before COVID to now, because I think like it's especially like good for Mohammed, who did our intro, because he's interning with you guys right now, and he's able to be on site and do everything on site. I know like so many other internships got either canceled or they're completely virtual right now. Do you think, like, how valuable do you think that is to be able to do something in person instead of virtually or even canceled?
At least from my perspective, I think it's very valuable because you know, the reason why, at least from what I can gather, the reason why we do, you know, 8-month co-ops instead of, you know, 3-month summer internships is because it takes many months to be able to, get up to speed on our, on our lingo and, the products and the processes. It takes a while to even, come to work and be able to figure out anything, understand what anything's going on, just because of how specialized it is, kind of. So it's much easier for us, to show Mohammed, in person, and kind of explain them, show him, than, just tell him to look at some drawings and some pictures and, tell him to imagine how it looks or whatever. So much easier to do in person.
Yeah, I will say that, that I feel the things that got me through my interviews were my co-op experiences. And then for me, I transitioned from my co-op into my first full-time position with the same company. So without that experience, I wouldn't have, this thing on my resume and a track record of performing. And John's right that an engineering co-op, even if you have a short one and you're given a specific project, to be able to have that big picture view, like we talked about earlier, of appreciating all the other facets of engineers that you have to work with and understanding how your piece fits into that bigger piece, really is a lot harder to do virtually. And I think the whole going to work and working on a project or working on these tasks, it really helps build that work ethic and you're grinding the gears, you're figuring out, okay, yes, I want to do this for the rest of my life, or no, maybe I want to look at something else. And the co-ops and the internships are the perfect time to bounce around and get all that experience. And it's only going to help you long term.
Oh, absolutely. Especially, I think in person has I think it's more valuable than doing it virtually, just because you really almost get to see everything like in person. Obviously, you get, like, if you don't like something, it's very obvious, and if you do like something, you'll be wowed by it if you see it like in person. If you see like whatever you're working on, like the aircrafts, everything like that, that's when you really have that wow moment of, okay, do I really like this or do I not? You'll know. You'll know immediately once you see a fighter jet or anything. If that's like a wow moment for you, then you probably like that a lot.
Yeah, and I would say to the people that have the virtual internships right now, that they're still valuable, right? You're pivoting, you're showing adaptability. That skill, you don't know what that's going to mean in 10 years if there's maybe another pandemic or another event that requires some kind of global pause to what we call normal. You're going to be that much more prepared because you've gone through something similar. So there's still opportunities, there's still lessons to be learned. But yeah, I think definitely engineering hands-on is preferred for sure.
Yeah. And especially, if you're in a co-op or internship, the networking, the face-to-face networking is actually very important, to be able to find something after. So.
Yeah, that's great that you guys are doing these virtual podcasts and events, because I remember, attending a very similar event to this when I was running our IEEE group in college. And I can't tell you how many people talk to presenters or network with presenters either there or after the fact via LinkedIn or email. And that's how they got hired.
Yeah, I think we've actually had a couple people reach out to our past guests, and they have actually been able to like maintain a conversation and get interviews. So that is true. That I think it is valuable. Absolutely.
Yeah.
Kind of shifting back to almost like the technical side of things. I know you guys just got hired in 2019, so maybe not restrict this only to Collins Aerospace, right? But what is your favorite engineering project that you have done?
Probably, I guess I'll go first. My favorite engineering project that I've done, back when I worked at Sub-Zero, they were pivoting their product lines to start going into the connected world, right? So the IoT, being able to remotely start ovens, check the status of your fridge filters, see if your dishwasher was done, all of that. So I got to kind of work in a new product introduction capacity by bolting this new, connected module onto all the products. So there's existing products, but we added connectivity to it. And I got to see all the facets of what goes into that, the software design, the interfacing, what that meant for our factory. We had to make sure that all of these things could connect to the internet and get all their certificates and things like that, so we could do this securely. And I got really involved in rolling that out, and that was super exciting for me.
All right, so it's almost, was it kind of like an almost like an IoT project then, or not really?
Yeah, pretty much. I mean, it's exactly what it was. Your phone became an interface to the products. So you, like I said, you could remotely start your dishwasher if you forgot, or I'm on my way home. I know I'm not gonna have a lot of time tonight. Let's get the oven preheated. Fridges weren't necessarily the most exciting in terms of features. You could turn your ice maker on, put it in vacation mode. But if you think about the luxury brand of appliances, maybe these things are in your summer home or your vacation home, where you don't want your appliances running full bore all the time if you're not there. So you could put them into like a hibernation mode where they use a lot less electricity, but then, okay, now I'm coming there, or I'm throwing a big party this weekend, I need more ice to be made. So a lot of those things were the end user perspective, but on the back end, all the infrastructure, talking to the cloud, and the testing of that in the factory is really where I got involved. So a lot of Bluetooth and Wi-Fi communication experience I got there.
Yeah, I've honestly kind of I've seen those refrigerators with the big touch screens, and I've kind of wondered everything that they can do, because I've never got to play with one yet. So that's cool. What about you, John? Do you have a favorite engineering project?
So at least the last couple of years, my favorite projects have always been the MPI, so the new product introduction projects. Just being able to kind of start from, so like where I come in is, they already have the rough design of this new display built. They want to test it to these requirements and all that. So that's kind of where I'll join in on the project, is being able to help sway that we want it to be tested here, we want to use this and that and all that. So that's always pretty fun, and just being able to watch the the flight display get developed at the same time. To be honest, probably my favorite engineering thing that I've ever done actually wasn't when I was a senior in college, and we actually did a IEEE competition robot, automated autonomous robot. That was actually still probably my favorite engineering thing I've done, just because we literally started from scratch. Our professor just like, have fun, it didn't really give us any help or guidance. So me and my friends, we developed a fully autonomous robot from, well, autonomous. It wasn't very smart, but unfortunately, that's probably why I didn't win. But that was super fun, just to be able to develop it from bottom top.
Yeah, I'm sure that mechatronics classes came in really handy then.
It did. So this was, I don't know, 3 or 4 years ago probably, and we had the coolest looking robot. But it was not very functional. It wasn't the least functional. I'll at least give us that. But
well, they have to add in the looks contest, right? The aesthetics contest.
Oh yeah, well, we definitely won that one. So
that's funny. And I guess almost bouncing off that question, is there a favorite aircraft that you guys have, since you guys are working in an aerospace company now?
So my favorite aircraft, I would say at this point, is something that's not even fully developed.
Those are the best ones, yeah.
If you've heard about the FARA or FLARA initiatives, they're basically the U.S. Army's approach to future vertical lift. And
okay, yeah, I've seen that.
Right now, John and I are actually both working on some flight displays that are going to support those platforms, whatever they may be. We have our solutions that are going to be ready to go to market on those. But what's really interesting about those is they're being built with this idea of an open, connected ecosystem. So it's called MASA.
Mm-hmm.
And I'm really excited to see where that goes, because that's opening up opportunities, for you to adapt an aircraft for a specific mission. Maybe you're going to, do a reconnaissance mission, or maybe you're like with the Coast Guard or something doing a rescue mission. Having this open connected ecosystem in an aircraft really is going to allow you to plug and play different modules that you need to support your mission, but then that also helps facilitate the future upgrades of your aircraft. Because one of the things in aviation you'll notice is it's a kind of a slow industry in terms of technology advance. Like the new product introduction and the research labs are always, cutting edge, but by the time you get the approvals and all of these things to happen with the FAA to make them safe, make them tested, make them well understood, that product, that technology could be 10 years old at that point. And with this connected ecosystem, it's going to allow much more plug and play. So as soon as things are approved, as soon as things are ready to go, we can bolt those onto an aircraft and make it better.
Yeah, that almost sounds like similar to your favorite engineering project with IoT almost, right?
Mhm.
You can turn on your airplane from your house or whatever.
Yeah.
And I saw I think like just last week I watched the video, the F-35 like turning its its engine so it can point towards the ground. They can like lift up vertically. That's crazy. That's so crazy. That's really cool.
Yeah, it's funny you mentioned the F-35, because that one is actually, I think, my favorite, just because of all the technology that's packed in there. It can take off from a standstill, land, whatever. It's stealth. It's it's got the helmet on it. Actually, we built, Collins built that helmet, right, Alexander?
Mm-hmm.
Yeah. So I mean, I've never actually got to put it on, but apparently there's the demo at the same plant that Alexander works at. And so you'd actually kind of put it on and kind of see what they would see in like a cockpit, and actually kind of look through basically the aircraft, right?
Yeah, you can look down and you don't see the bottom of the aircraft. You see what's there. So that's really cool.
Yeah. So that was pretty cool. Unfortunately, the only thing we make for that F-35 at the plant I work at is literally a wire harness. So what we make is a very exciting at that plant, but I think it's still super cool.
Well, you said you actually got to put on the helmet?
That's pretty cool.
I never have, unfortunately, but they have they have a demo thing. Did you ever do it, Alexander?
I have not, but I've talked to several people who have.
Yeah.
So maybe after COVID, we can see if we can get a in-person demo.
Yeah.
Oh,
That'd be
please
awesome.
get one for me. Get one for me. I'll pay however much I need to.
Come get an internship with us, man. And then
I'm gonna. Oh man, don't tempt me. Don't tempt me.
All I'm saying is in Cedar Rapids, they hire a couple thousand co-ops, I'm pretty sure, per year. Just if you go to the website, pretty much like 90% of the job postings, so at least currently, are just like co-op. So, and pretty much most of them are in person. So
I'll see you guys next year then.
Yep.
See you guys next year.
See you guys next year.
With Muhammad.
I guess stem from that, how far do you see technology advancing for aircrafts? Like,
that's a great question. I mean, technology in and of itself is always evolving. There's really the only bound is our imaginations. Practically, what technology makes sense in an airplane. Yeah, there's definitely limits to that. We're not gonna necessarily implement something that's not going to be useful to either the passengers, the pilot, or the crew, or anything like that. But I think there's always room for improvement. I think we're going to get better and better with higher speed communications, more data going back and forth, smarter aircraft that are able to identify to the ground in real time what's going on with their systems. Think about, I've been traveling for business, and just being able to get affordable Wi-Fi or faster Wi-Fi in a flight, that's something that I would look forward to as a consumer, just being able to have that as a passenger. But I think there's all kinds of areas that we can continue to grow into.
Do you think that vertical flight is probably one of the up and coming ones?
Yeah, definitely. I think, you know, the commercial industry is kind of has similar things, and I think there's going to be this adoption of a more open and connected ecosystem, and that's going to drive competition so that prices will go down. And as soon as that happens, it's easier to implement things into non-military aircraft, right? We can make something very specific and very expensive for the mission that it has to do. But if we have this connected and open ecosystem, maybe some of those products, you know, bridge the boundaries between being solely military or solely government and go on to the commercial side and vice versa.
Yeah, hopefully, yeah, if that's possible. I have actually one more question kind of relating to the helmet. Do you guys ever get to like talk to the pilots or like get them to try something on or like use something and get like feedback directly at all?
Not me, at least. You know, pretty much we make it, we send it to, so you know, if it's like a new product thing, you know, we'll make it, we'll test it, and then, you know, we send it to some engineers who actually do like the system level integration, and, you know, for like and, you know, so they'll actually be talking to the pilots, test pilots, and all that kind of stuff. So
Yeah, I would say I haven't had any direct, you know, end consumer interaction to date. I got to see one of the test aircrafts, one of our test flight aircrafts in person. And the pilots were there, but there was a long line to talk to those guys. So I didn't get a chance to do that, but we do get emails and we do get to celebrate, you know, we've just completed our flight test. We just got our approval, that kind of stuff. I mean, John, we just got an email a couple of days ago that they completed one of the first flight tests on some displays that we just transitioned. So from that side of things, we get the celebratory feedback that, hey, we did this. This is awesome. Excited to see where this goes. But yeah, I haven't had any direct end consumer contact yet.
Well, yeah, I would imagine that kind of happens more when during the flight testing, right?
yeah.
So, but you guys did mention that you guys do test the flight displays before you send them out somewhat. How does that testing differ from maybe like the flight testing that ends up going on afterwards?
Yeah,
Want to take that one, John?
yeah, go for it. You're the one with the magic words, Alexander. So,
well, I think we're definitely both gonna have a perspective on this. So, as with anything, there's the qualification period. So that's really where you're doing your design validation. The testing we do in the factory is more or less, did we build it right? Are all the pieces that we need assembled correctly? You know, getting down to the chip level, the resistor level, making sure that all those things are functionally working. And then the flight test is really, okay, let's put this thing through its paces. Let's understand where our margins are, because, you know, you go through college and there's this right and wrong answer, and it's black and white, and there's hardly any of this gray area. But, you know, FPGAs that run things, although they're near real time, they still have limitations. You know, there's still delays, there's still things that can happen. So the flight test is really to identify where are those boundaries, and then what redundancies do you need to make sure that are there and are working in case you encounter some of these situations. So they have to get so many hours of flight time and so many hours of testing after the fact to even get the approval. But John and I have much more, I guess, direct impact on the factory side of testing. So making sure it's built, like I said, built right, functionally ready to go. And then supporting sometimes any upgrades or service bulletins that we would add to a product, maybe that's been fielded and now needs a new capability added to it.
well said.
Okay. But I imagine that there's also like testing that goes on when the new product is being developed, right? Like stress testing and shock and lightning, I imagine.
Yep.
Yep.
Yeah, all of those environmental tests, even in the factory, you know, we have some environmental tests to do just to make sure that if you experience temperature changes or a little bit of vibration, that the product's going to survive like we say it will. So, but yeah, the whole qualification process, you're right. You would see all of that: accelerated life testing, lightning, humidity, salt fog. I mean, whatever the conditions of this display are going to be in, kind of on their day to day, you try to replicate and get X number of years of data on in a very very short amount of time, so you can make this product to market.
Yeah, I imagine there's definitely challenges that the aerospace industry like faces that maybe other engineering industries don't really face, because everything has to be lightweight but also durable and like can resist like so much vibrations. Is it kind of like annoying, or do you think it's really difficult sometimes to bring a new product to life because of all those check marks that you have, or checkbox that you have to check?
The development costs, so to be able to like the development cost of like a flight display for instance is many millions of dollars, because of all the testing that has to occur and all the validation, because if it goes in the aircraft, it has to be essentially 100% sure that it will not fail, and if it does fail, it will not cause like a safety critical problem or anything like that. So yeah, the FAA, they have to prove things, the things that go on other aircraft, so have to be proved in European stuff. I'm anticipating. So the approval process, just to be able to start making them and using them for flight stuff is, quite a bit.
Yeah, and I think the other constraint that you work on in the aerospace industry is, in addition to the extreme environmental conditions, right? You have to be rugged. They have to operate across wide temperature spectrum. It's also got to last, right? I mean, our cell phones, every couple of years, well, every year there's a new one, but every couple of years, maybe you replace it, and you forget about the old one. But these other things are going into aircraft, are going to be flying for many years, and the mean time between failure has to be pretty low in order to support all of the commercial side of things, where you have passengers that can't be without a plane because they got to get to where they want to go. So I mean, John's well aware of this. In the factory side of things, you're supporting products for 30 years, just to make sure that the life of an aircraft out there is supported throughout its lifetime. So that's another thing, is that supporting side of kind of the legacy stuff is super critical to the industry. And you don't see that with a lot of the consumer side of things. Like I said, phones, computers, appliances. I mean, whatever it is, those things are kind of built to only last so long, and then you get a new one.
But yeah, we do occasionally get a CRT flight displays that are like 30 years old, 40 years old, back in our plant. So yeah, in it for the long haul.
Yeah, everything has to be reliable, because it's still very dangerous to fly any plane, obviously.
Yeah.
And when you do design these things, I imagine you guys want to be able to design it so that it can meet as many requirements as possible, so it can go into as many aircrafts as possible, and it can be sold as many times as possible. Is there like a balance between, okay, we're designing so it can meet every requirement, and just maybe under designing a little bit, but being able to produce it more quickly?
I mean, to me, to my vantage point, like, because we make a lot of different versions of different flight displays for different aircraft at the plant I work at. So, so it seems to me, that if they have a customer, who wants this functionality in this form factor, this weight, they'll just kind of see, if there's not one that we already kind of make, that already makes the checkbox for the customer, they'll start designing a new one.
Yeah, I would say we're very customer driven, and we try to get ahead of the market, because you kind of get a feel for what people are looking for. For example, with the future vertical lift, there's a base set of requirements out there that were posted that, hey, if you want to be part of these platforms, here are the things we're looking for. So you kind of try to design around those. But to John's point, yeah, you're right. a lot of times too, it's maybe they really like a product we already have, but they want a tweak. So they'll add another interface, or they'll add a different form factor. So it's maybe not a complete redesign from an engineering perspective, but from a form, fit, and slightly functional piece, we're either extending something or duplicating something. So we're able to kind of adapt on that level. But I would say that the customer is always right from our perspective, that all the designs are based on what someone else really wants.
That makes sense. So it's almost like that you're almost like contracted, and they tell you what they want, and you'll see, okay, can we make this with existing hardware, or do we have to like completely make something new or something like that?
Yeah. I mean, so some of these fight displays are, not like your couple $100 iPad, or anything. They're, 10 to a couple $100,000 a piece. So they are very expensive, and so the customer is very picky about what they want, and so is, of course, all like the certification stuff is very picky.
So for you guys to be where you are, did you have to get your FE and PE, or did you just go straight into this role essentially?
I just went straight into this role. So we don't necessarily have the authority that, we're not part of the guys that are saying, yes, I put my stamp on this and I approve it, and that I have not found fault or anything with it. But we do have, I'd say, an earlier feedback loop in the process, where we definitely identify things that are concerning during the manufacturing process. Prototypes are kind of a mixed bag. Sometimes you just like, well, that didn't work out the way we expected. So there's, you go back to the drawing board, and we try to give that feedback as early as possible to get those things corrected. But ultimately, we don't have the final say, but we're definitely, we sound the drum if there's something going on with the product, for sure.
Yeah. Especially in like the, the existing production stuff, fairly often, we'll find something with a, board or top level display or something like that, a problem in the factory. And, so then we will have to make sure that, that none of them got to the customer, that we're not compliant, or potentially will have this issue. But
yeah, right. And there's all kinds of challenges. So if you think about the electronics industry, like we were just talking about, how things are disposable and always changing, they may only make a certain chip for so many years, but we're trying to support this thing for 30 years. So you're trying to find alternates, you're trying to find replacements. And as you try to make those upgrades and get rid of obsolescence and things like that, you don't want to go through a whole nother development cost of redoing a display for one chip. So there's definitely pain points, I'd say, integrating some of those things as well, that the factory catches, and we go back and forth with our designers to get the problems fixed before they make it to the end customer.
From both your perspectives, as a college student, do you think it's worth it to try and go for it?
Absolutely. I mean, you don't know, like I said, what you're going to like. You don't know what you're going to end up doing. So having that PE certification definitely is going to open more doors for you. But I think that shouldn't be taken lightly. And even if you don't have that, as engineers, we're shaping the world every day. And there's things that, even though John and I aren't signing off on officially, if we don't sound the drum, we have a lot of people's lives in our hands, right? I mean, that's ultimately, at the end of the day, there's thousands and thousands of people flying aircraft. And if it's something that, we missed, even if it's not formally our fault, we have a part of that. So I would say, even if you don't get the PE, definitely approach engineering with that mindset of, you are responsible for what you're making, what you're producing. And you have that responsibility to everyone around you as an engineer.
Yeah, I agree.
That's really interesting. And also, Alex, I saw that you're pursuing your master's in engineering management. So are you guys both like, what's the word, for, furthering your education, or again, just follow what you feel is right? even if you don't know what's right, you know?
Yeah. So as an engineer, I try to never stop learning, right? And pursuing my master's in management, I'm kind of doing a hybrid of a degree. So it's a little bit like an MBA and a little bit kind of like more of a theoretical type technical of how do you design products degree. So it's kind of a weird mix. Just the title of it is just Masters of Engineering and Science, and you kind of pick your emphases. But one of the things that I think is attracting me to the management side, and that's both of people and projects, is being able to shape the long-term bigger picture of whatever it may be. You know, if it's for employees, it's getting to help them see them grow and develop. But then also having an engineering background, understanding their problems, right? And engineers have unique problems that they try to satisfy and get solutions to on a daily basis, in addition to all the human things that everyone goes through. You know, you have to call in sick, or things are going on interpersonally that, you know, a manager has to deal with as well. But then having the engineering background, you're also able to help guide and support them in their projects and in their struggles on their work side of things. And then with the other half of the degree, really getting an appreciation for how to design for manufacturing and how operations works is not something that I would have been exposed to, you know, with a canned EE degree, but it's definitely something that's very valuable to the work that I'm in right now, and where I see myself kind of growing into. So I would say never stop learning, even if it's not formally. There's always trainings, there's always seminars, webinars. You know, you can absolutely learn something new. Can never have too many tools in your toolbox, especially in our roles.
Yeah, I agree. I'm not, formally going for my master's or anything right now, but I will eventually. Many companies will actually, pay for extended education, such as ours. So they will pay for master's degrees and whatever. It is something, of course, just being an engineer, that I always have quite enjoyed the learning, big learning new things, figuring stuff out. But at the moment, if it's just a YouTube video, I'll watch them. There's something new, I'm still pretty happy about it.
So what led you to that master's specifically? Was it just working, or like, as soon as you enter college, I'm gonna get my EE degree, then go straight into this master's program, Or I guess to put the question more broad, what led you to engineering in general, to both of you?
Sure. Well, I guess I'll start with the engineering piece. So I definitely knew I wanted to be an engineer from an early age. I didn't really know what the formal term of an engineer was at that point, but I knew I wanted to be, a problem solver. And that's really what engineering is. You're a problem solver. I started kind of dabbling into, okay, what kind of engineering do I want to get into? And frankly, I didn't know that I wanted to settle on electrical engineering right away. I thought I was going to be a mechanical guy, but then after I started taking some high school courses, I was like, this is cool, but I'm not able to achieve kind of what I want. And the electrical side, I felt like I was able to put more things in motion with circuits, with some of the kind of computer programming type stuff. And that's really what set me up on the path. Now, when I graduated college, I swore off a master's degree. I said, no way am I coming back to school. I got my degree. I'm going to go out in the industry, just work as a worker bee engineer for the rest of my life. And I was totally happy with it. I am happy with that. That's what I'm doing now. But in keeping those doors open and having all those opportunities still ahead of me, getting the master's at this point is kind of a perfect spot in my life for me to do it. I have the time right now and the ability to kind of go back to school. So I'm just kind of knocking it out. And if I use it in the future, great. If not, there's definitely lessons that I'm learning as part of the master's degree. And a huge part of engineering is it has actually nothing to do with the technical side, right? You're going to get assigned a project or propose solutions for things, and you're going to go back and you're going to do all the technical things and propose a solution. But after that, you still have all the other things, right? You have to convince someone that my solution is the best, because there are no like wrong or right. It's just better and best kind of things for solutions. So you're still having to communicate your ideas to someone else. You're still having to convince someone, hey, you should spend your money with my solution, even if it's internally to your company. You're convincing your manager, you're convincing a program manager that this solution is the way we should go, and this is why. So having those communication skills and being able to communicate very difficult and complex engineering concepts to anyone is a huge skill. And that's definitely something that I'm seeing highlighted a lot in the master's work I'm doing, is being able to take some of these concepts of engineering, but then also applying them more practically to a lot of the different aspects of an engineer.
I actually have a question bouncing off of that. Do you think obviously everybody is going to be a lot more motivated doing the project that they have the vision for, right? So when you're trying to convince someone that your solution is best, you really want that, but it can be really tough sometimes for them to trust you, especially if if you're like just an entry level engineer. Is there how long do you think it takes someone to finally like trust you with a solution? And do you have any advice for people as entry engineers trying to do that?
Yeah, so I would say always be customer centric with everything you do. Even if what I make, I'm not just talking about the end customer that's going to sit on an airplane, but whatever I produce is going to be consumed by someone else, or someone else is going to use my piece of a project that I'm working on. So having the mindset of, again, how does my piece fit into this bigger puzzle helps you to build those relationships with people and establish that trust on a lower level, so that when it comes to one time for these projects to be introduced or for you to pitch your ideas, you've already built a little bit of that trust. And I would say, you just got to sell yourself or sell your idea. Like always, there's always going to be someone smarter in the room than you, or with better ideas. But it's getting that communication aspect of why yours is better, or maybe you can learn from your mistakes and you can learn from other people's mistakes. So if you're not making those mistakes that you've been in, or someone else has made, and you're like, oh, those things really annoy me about that person, well, don't do them. And then that just helps solidify your presence and your ability to get more people on board with whatever you're trying to pitch.
Yeah, so it sounds like it's almost like a combination of obviously having a good solution and having the interpersonal skills to like convey your solution in an appetizing way, I guess. And also, I guess, staying grounded and focused on the mission at hand, right? You don't want to make something that you just want to make. You need to make something that will help the customer and the company, probably.
Yeah, because there's always different ways to do things, right? But if an engineer decides we do this because it's best because of for whatever narrative that he's looking at, but then it gets to manufacturing and it is takes 23 hours to assemble, or whatever, just throwing out random numbers, and everyone else down the chain kind of absolutely hates it, then it's not necessarily a good solution. So just need to make sure that you're looking at the full picture and not just one little tiny thing in a big company like ours, at least.
Yeah, I think definitely because of time and scope of projects, engineers get the requirements document and say, okay, I'm going to make sure I check every one of these boxes. But in addition to checking every one of those boxes, you have to, like John was saying, think big picture. Who's going to be the end user of this? How can I make this usable? Because you can make something that checks a box, right, but is like useless. And our favorite example from working together is probably like the check engine light, right? It's the best invention ever. Something's wrong with your car, but immediately you panic because you have this yellow light on your dash and you have no idea what it means, right? So whoever invented that, great, you alerted me there's a problem, but now I don't know what that means. So I mean, now you're seeing on cars with displays and phone connectivity, they can say, okay, oh, your spark plug on cylinder 4 is giving you misfires or something like that, and that's both of those solutions check the box of display an alert to the end user that something's wrong, but which one would you prefer to actually have, right? The little blinky yellow light, or the one that tells you what's going on with a little bit more context. So those are the types of things that when you're going through requirements that you ought to be thinking about. And as you do that, you get more credibility. Back to your point, Juan, about how do you sell a project? You have this foundation of credibility of I'm always thinking about everyone else and making solutions that are going to be good for the big picture. That helps build your trust with those other individuals.
For sure, you gotta remember that you're part of a team also, and make sure you're making something that everybody wants to be. There's probably nothing worse. I mean, at least from my experience, there's nothing worse than just people who don't want to be doing the project because they're not motivated, because they don't, they're not making something that they see a future for, or a vision with, or something like that. But yeah,
So
kind of almost circling off the like projects that maybe haven't been successful, or pitches that haven't been successful. What do you think your guys' biggest failures, and what do you think you've learned from it in engineering?
Oh man, we're gonna be talking for another 3 hours if we go into all my failures. I don't know that I can point to one big failure. I mean, if I wrap them up, most of my failures were around not thinking big picture. I mean, even academically, I sit through class, and I vividly remember to this day a situation where I was in my electromagnetic fields class, and our professor was going over about this spherical capacitor theoretical thing, right? There's a center sphere, and then there's this outer shell, and what's the capacitance, and what's all of the criteria for the dielectric and all that. I'm like, when the heck are we going to use anything like this, right? And it took me until probably a year and a half into my co-op, or maybe it was after I started full time, that I didn't necessarily need to know all the triple integrals around that, but the concept of that actually played out readily in a refrigeration issue. So we have a compressor with a piston in it, and the compressor is basically spherical, and the piston was almost spherical in the center. And part of the appliance testing to be UL rated, you have to do different verifications, and one of them is a high potential voltage test to make sure that there's no breakdown between the wires and no one's going to get shocked, etc. And so I had the outer shell of the compressor, refrigerant gas in between, and then this piston in the middle. Well, it turned out that if we didn't have the refrigerant gas, if that didn't get piped into the refrigerator properly, there'd be a dielectric breakdown. And from the piston to the shell of the compressor, you have this arc. And I'm like, whoa, the thing I said I would never use in my life, absolutely not, just played out here practically for me. Again, I didn't need the integrals to understand it, but having that conceptual knowledge of, okay, this actually is useful. And I have moments like that all the time in my life where I'm like, I swore I'd never use this. This was just some textbook thing that they wanted us to hash out to give us busy work. And I see it all the time that they play out. I'm just like, man, I wish I would have paid more attention or dove in deeper on some of those things and not written them off. So I'd say that's probably one of the areas that I failed. And that's why I continually try to look big picture and taking lessons from every aspect that I can, interpersonal, engineering, anything.
Yeah. I mean, when you do end up failing, if you miss a deadline or on the job, or you mess up a test or whatever, it is really important to not just try to block it out of your head and be like, man, there's no way this was my fault. It was this person. It was that person. It's important to really kind of deep dive into your own mind and be like, well, what could I have done better? And if that ever happens again, what can we do to make it more effective, or make it better, or whatever, instead of just blaming someone else for it.
Yeah, John, you hit the nail right on the head there. I mean, owning your mistakes is huge. And you learn from it. Everybody else learns from it, and you just keep building on those.
In the industry, you know, no one really cares if you make a mistake unless you're just like, you know, dig your head in the sand and or you know or whatever, and you know, act like, you know, there's no way it's my fault. You know, if you just own up to it, you know, everyone's just like, okay, what could we do to make it better? What could we do to prevent that from happening again? You know, and everyone just kind of moves on.
So Alex, stemming up from what you said before about, you know, I'm never going to use this again, it kind of got me thinking, to actually both of you, what kind of students were you guys in college? Like always on the grind, studying, or just very laid back, very chill, you know, C's, get degrees type of vibe?
Well, the ambition obviously was always for the A, right? Always for the perfect everything. Practically, I would say I was an average student. I didn't maybe spend as much time on the actual schoolwork itself that I could have, you know, looking back. But I definitely put the effort in. Where I really thrived was in the lab work and the projects and the hands-on and making something real, right? Especially in electrical engineering, the mindset you develop is you're translating all of these imaginary phenomena, phasors, imaginary numbers, all of these things into trying to manifest it into something real. And I think that gives electrical engineers a unique perspective going out in the industry. You know, I personally, I've seen more EEs get degrees outside of their job formally because of that mindset that they develop or they've had, and that's why they chose to be a double E, is because a lot of engineering aspects, you know, other majors, you're taking the invisible and making it real, or trying to demonstrate it in a physical means. But like electrical engineering, that's like all of it. There's very few things that you can see until they're catastrophic, right? That what's going on with an electron. So that I think is kind of where I ended up. I was more of an average student, but really enjoyed the translating of the theoretical to the physical.
Yeah. Alexander and Mohammed probably might have realized what kind of student I was now, or what kind of student I was in the past, because I still cannot write down anything and, you know, remember to write anything down to actually help me, you know, in the future. So you know, I was never good at taking notes. You know, this was throughout my life. You know, so I was always much more of a pay deep attention in class. You know, to try to memorize it. You know, well, just learn it all, not memorize it. You know, to learn it and try to understand it. You know, and my way of doing that was just not writing down. It was just paying attention in class. You know, so I always did well in school, but I was always not very good at writing anything down, or, you know, remembering it for, you know, super long term. You know, but you know, I did fine. You know, well over 3.0 GPA and all that stuff. But
Yeah, and having done, so I've done a little bit of co-op recruiting, and even through my hiring process, I actually was never asked my GPA at all. They really wanted to see how I worked with the team, what my experiences were, and what I could bring to the table. They know that if a college, and you know, an accredited college is giving you an engineering degree that has a history of producing good engineers, you're most likely going to be a good engineer, right? But you got to figure out what differentiates you from all the other applicants, because there's maybe 10 other people from the exact same school with the exact same degree with a GPA that's, you know, a tenth or a thousandth away from yours. So there's things that make you differentiated that I think really ultimately are what's going to kind of set you up for the long term. Now, obviously, you have to have a threshold of the GPA, right?
Yeah.
You kind of weed certain individuals out, but I've definitely seen that, you know, not the highest performing GPA people are still some of the very smart people. They may not be good at tests or getting their homework done, but when it comes to executing and being creative and doing those sides of the engineering, you know, they're phenomenal. So
I guess to put you in a more like situational question, let's say you were in person recruiting somebody, right? And the first person is your stereotypical like engineer, kind of robotic personality. But he has a great GPA, 4.1 somehow at a 4.0 GPA type thing. And then, but he has no personality essentially. Then we have this other kid that walks after him. He has 3.0, but he has a great personality, and you can tell you're gonna enjoy working with him. So at that point, who would you pick?
Well, I would say one of the other criteria I would like to see is what they've done, regardless of their personality. You know, if they have a proven track record of, hey, I've done this project or I've been through these situations, that might influence me. But on the other side of it, you're right. I'm going to have to work with whoever I pick, either as a co-op or a full-time engineer, potentially for a while. And if I want my job to continue to be not a job for me and something I enjoy to do, I'm probably going to lean more towards the people that are personable and I would enjoy working with, you know, for the next 10, 15 years or whatever it may be.
Do you think college prepares for that?
I think so.
Okay.
Oh, I
I
might
kinda
not have
cut
heard the
off.
question.
Yeah.
Okay.
Do you think college prepares you for both the technical and interpersonal aspects of engineering?
But there's certainly, you know, ways such as like IEEE, you know, to help expand, you know, your knowledge of just outside the classroom, right? You know, so there's always all these different clubs and groups and all that stuff that you could join in college to you know, kind of help to develop your, you know, interpersonal skills. And, you know, IEEE has conferences and all that, and, you know, you go talk technical stuff with, you know, other engineers. You know, so I think there's certainly aspects of college, you know, outside of just the classroom that definitely helps you prepare, which is, you know, why, you know, you don't just get a automatically great job, you know, just because you have a 4.0 and you went to this school. I mean, you know, if you don't have any experiences or anything like over that, or stuff like that, you know, it's not a for sure thing.
Yeah, I would say college has the opportunities, but you're in charge of preparing yourself, right? You can select your courses and navigate that, but you know, taking an English or communications course might not be on your radar, but is it going to help you long term? Probably. So either, you know, get those things through clubs, extracurriculars. You can kind of set up your educational path and make sure that you're well rounded, and because the opportunities are there. And that's what universities are for, is to provide a broad range of different perspectives and things to get educated in. So the opportunities are there. It's you having to help shape your own path.
You know, obviously you guys are very smart, very well spoken. So what advice would you give a freshman that could be watching this right now that you wish you knew to, I guess, end up where you are?
John, are you ready for this one? I don't know if I have to think about this.
No, not really. I mean, to be honest, a lot of what I've personally done is just kind of just stumbling upon things, you know, like, oh yeah, you know, go to this school and do this degree, and then, you know, I'll end up in Iowa and end up at this job. You know, so a lot of it's just in my life, it's just been, you know, just random happenstance and whatever. But you know, every time that I meet this new thing, I do try, you know, my absolute hardest to, you know, to try to understand things, to try to, you know, just do my best, if that makes sense. You know, make sure that the excuses for failures are, you know, as minimal as possible. You know, so you can't win them all, but, you know, if you try your best, you know, you can at least do what you can.
Yeah, I would say I'm kind of in that same boat. Definitely going with a plan, right? Have a goal, have somewhere where you're going. But if you get sidetracked or things, you know, deviate from that initial plan, that's fine. Just help those shape where you're going now.
Yeah, exactly.
I never thought I'd be in Iowa. I never thought I'd be in aerospace, right? I mean, that was not anywhere on my freshman year map. But that's how it worked out. And I don't think any regrets going back. Everything that I've done whether it was a failure or success, I've learned something valuable from it. So keep your eyes open, and go with the flow.
Yeah, I was gonna say, don't be afraid to do something else, and just adapt from there. Just be adaptable, because you never know what's gonna happen.
And ask questions. This is something that John is really, really good at. Definitely more than me, because I will sit in some of our conference calls while these engineers are throwing around acronyms or words that I have like no idea what's going on. And John is like always like, hey, what does that mean? There's 4 letters you just smushed together. What does that mean? And I'm like, man, I was thinking the same thing. Thank you for asking it.
Yeah. Everyone, in past college is going to be more of like, well, if you didn't understand that, why didn't you ask? Instead of getting annoyed that you're asking something that might be basic to them, certainly not basic to someone else.
Yep.
Yeah, it does take a little bit of courage sometimes to say that you don't want to seem dumb, or you don't want to seem like they've been talking about this for a while and you just now want to ask it or something. I don't know.
Yeah.
I've experienced that before for sure.
Yeah, well, every time we get a co-op, and I try to tell Muhammad this too, is don't be afraid to ask too many questions. Especially when you're co-op, we know you don't know anything of this stuff, because it's very specific industry related stuff. We know you don't know any of this, so just
we know you have a question. We know you're not asking a question.
Yeah. So once you feel like you know enough to actually ask a question, feel free to ask all the amount of questions you can.
It's alarming being on the other side of interfacing with the new employees or the co-ops, and they don't ask questions. And it's like either you know way more than me, or you're not getting enough out of this yet. So ask the questions. It helps your understanding. And John's boss, who was in our role until recently, he became a manager now. That was one of the first lessons I learned from him, was why. You ask why 5 times, and eventually most people's answers break down into, well, that's just the way we've always done it, or that's how we do it. And that's not a valid excuse for anything, right? You want data-driven decisions saying, this is why we do it. This is why we should do it. So asking why or how or all of those questions, even if you're not intending to change anything, ultimately, it helps your understanding and helps you get that bigger picture. So.
Absolutely, yeah. Well, Fernando, if you have any more questions, if you don't have any more questions, I think we're around the hour mark now. So I think just thank you guys for coming on and talking with us. I honestly learned a lot about the things that you guys do and about the avionics and aeronautics industry, obviously. So would you guys like to shout yourselves out for a minute and tell them where people can find you?
Sure. I definitely appreciate your time and for doing this podcast, guys. I think it's great. I'm hoping your reach is going to be great on campus. And yeah, you can find me on LinkedIn. I'd be happy to talk to you about anything related to the company or related to my path, any advice, even if it's you want to shoot me your resume for critique, like totally open, whatever, hit me up on LinkedIn.
Same, I certainly enjoy the podcast. So I always like just randomly talking about random stuff with Alexander. It's always fun. So so if anyone's got any questions or anything, just hit me up on LinkedIn. I can tell you I'm the only John Vodopich on all LinkedIn, so it should be pretty easy to find.
I haven't searched, but I might be the only Alexander Caracciolo as well. So.
All right. Well, thank you guys so much.
Yeah, thanks so much.
Yeah. We hope to see you guys again.
Yeah. Would look forward to that. Thank you.
Thanks, guys.